All right, looks like I stopped the video. I canceled it because I had a sneeze. And I was trying not to sneeze into the microphone. All right. Anyways, let's continue. So for this next example, we have, let's just kind of think about him and then I'll uncover the graph. So what do we have? So let's look at this next example. Here we have y equals 3 times sine of 4x. So we're going to do two things. We're going to actually stretch the graph of sine by, and instead of having kind of 1 as the maximum, we're going to stretch it by 3. So 3 times is stretched out on the y-axis. Now the 4 is actually going to compress the sine function, because so in terms of the notation, the a is 3, that we call that the amplitude, and it's a vertical stretch. The k is 4, and it's a horizontal compress. And you can see I started to write the formulas here for the period. 2 pi divided by k, since the k is 4, 2 pi divided by 4 tells us that the period is pi over 2, which really did mean it compressed it, right? It used to take 2 pi to do one full cycle, but now it's doing the full cycle in pi over 2, which is way, way shorter. It's like 4 times as fast. That's why there's a 4 here. All right, now look at how I came up with the graph. So basically, now that I know that the period is 2 pi, and I'm going to start at 0, 2 pi, and how did I get all these points? So basically, let's draw this picture from scratch, because I think this is an important lesson to do. So okay, let's do it from scratch. We've got all of this numbers. How do we get this answer? So we're going to put everything together here. Here's x, here's y. So let's start with the amplitude. Previously, the sign would only go between -1 and 1, but now it's going to go between +3 and -3. So let's go up 3, down 3. Now, the interesting part is the period is now pi over 2. So pi over 2 means it's really short, the period. So I have to cut up pi over 2 into 4 pieces. How can we do that? Well, cutting that in half is not too bad, pi over 4. But then cutting that in half again, we're going to get pi over 8. And then this third one, we have to basically figure it out. So because it's so tiny, I'm not even going to label them. So if you just label the last one in the middle, I'll be pretty happy. Okay, now what does sine look like? Remember, sine's going to start at 0. It's going to go up. So at this kind of first quarter mark, we're going to go up to 3, then back down to 0, then down to -3, and then back up to 0. So it goes up, down, up. Okay? So there's sine, and it's going to be very stretched out. And you know what? Since I'm just going to continue it a little bit in both directions and put my little arrows. Excuse me. Okay. Sweet. Nice graph. Next, what's this one going to look like? So we have a lot going on. We have a minus sign. That means it's going to flip everything across the x-axis. The 2 means we're going to stretch the y-axis. So we're kind of doing two things with that -2. We're stretching it vertically, and then we're flipping it. And we're doing that to the cosine. And then one more thing, the 1/2 x. So remember, the 1/2 means that we're actually taking it horizontally and we're stretching it out horizontally. So there's 3 things we're actually doing. We're stretching it out horizontally, we're stretching it vertically, and then we're flipping it as well. All right, that's a lot to keep track of, so let's write it down. So the amplitude is 2. Notice that the A is -2, but the amplitude is 2 because it's the absolute value by definition. That means we have a vertical stretch and a vertical reflect across the x-axis. Our K is 1/2. That means our period, T, is 2 pi divided by 1/2, which is 4 pi. All right, so pause the video. See if you can come up with this graph on your own, because this one's a little bit tougher, but these are the kinds of problems. And in fact, let's tag this one as a GTQ, because this is a good problem to prepare for our test. Okay, let's uncover the graph. I hope you tried it on your own. Here it is. So what I recommend that you do is you actually draw the graph of 2 cosine of 1/2s. So basically ignore the minus sign until the end, because you should kind of know what cosine does, right? Cosine starts at the top and then it goes down and then back up. And notice that I used that the period is 4 pi, and then I cut it in half. 4 pi cut in half is 2 pi, and then I cut that in half and in half again. So that's always what I'm doing. I'm basically always starting with my full period, which I'm calling it T, and then you basically cut the period into fourths based off of whatever you get for the period. That's going to give you the kind of the nice points on the cosine and sine functions, and that's how basically all I'm doing. I'm using these as kind of my markers to kind of jump between, and then I just know what the shape should look like, so I just draw the best kind of wiggly thing that I can. All right, we're almost done. I think we just have a couple more examples. Let's write this as a nice little summary here. Excuse me, I have a sniffly nose here. Okay, so this just adds 2 more things into the mix. The plus C all the way on the outside is really just a vertical shift up or down, depending on whether that number is positive or negative. And then there's this new number B, and I actually added parentheses in color so that you can see it's x minus b inside of those gray parentheses. That's going to be our horizontal shift. So you don't stretch it, you just take the full shape and you just move it to the left or to the right. So these are what we call rigid motions in math, because they're not changing the graph shape. The stretching does change the shape, right? You instead of like a really nice wave, you have like a really quick one. All right, so I have this pro tip here, and I went a little overboard with grabbing your attention. I put important, I bubbled it in purple, I have a light bulb to represent it's an important idea. Okay, so let's read through it real quick. It says, number 1. I don't know why this is highlighted. Let's highlight it in purple. Let's highlight all of them. Excuse me. Okay, so what does it actually say? It says, figure out the period first. Okay, and we have the formula, and I don't know what happened to my formula. This should be a K. All right. Once we have the period, then we need to figure out how are we shifting it. The B tells us how we're shifting it. So we're actually shifting 0 to 2 pi to B, and then plus whatever the period is. So actually I should call this 0 to T. Gosh, too many typos. I need a copy editor. Okay, once we've got the interval and we know where to start it and end it, cut it up into 4 pieces. That's our next step. And then finally, we need to decide if there's a reflection across the x-axis or not. That's whether A is a positive or a negative number. And then plot the 5 key points. So what do I mean by the 5 key points? So that's this one, 1, 2, 3, 4, 5. It's kind of like the main ones. It's where cosine is either, or cosine or sine are either the zeros or the 1 and the negative 1. So those are the nice values that are easy to figure out. So that's kind of your steps to follow. So from here on out, you just need to practice these over and over again. These are not very easy, so I do think you should do all the ICA, do as much of the homework as you can, and this might be a good one where you just do the WebAssign first, and then you try to do the ones by hand afterwards, since these are a lot tougher. All right. I think we have just two more problems, and then this last page, it's kind of a for you. Sometimes I like to do this ones, but you can safely ignore it. You don't have to turn in on the class notes. It's really just for fun. So these are the last two problems that we're going to do. And in fact, I'm just going to do number 6 and leave the last one for you to do in class or on your own. Okay, so here's our graph that we're looking at. We're looking at this as our example. So let's start just writing down all the things that we see. What is the A? The A is going to be 3. Since it's positive, it's also the amplitude. What does that tell us? Well, it's going to tell us that we have a vertical stretch. Okay? It's going to stretch it out. Excuse me. What's the K? The K is, I'm comparing it with this. It's going to be the 2. Okay? What does that do? It's going to horizontally compress by, and I guess I forgot to delete my 2 here. Compress by 2. Now, how do I know that I'm going to compress by 2? Because I'm going to use this formula. 2 pi divided by k. So since the k is 2, I'm going to do 2 pi over 2, which gives us pi, which means that that's our period. Our period is pi. So it had originally 2 pi as our period, and it cut it in half. So it shrunk it by 2. Okay, last number is the b. So notice that the formula has a minus sign as part of the formula. So here the minus signs are here. So the b itself is actually just pi over 4. Okay, let me say that again. The minus signs are part of the formula. So when I grab it, I really just grab just the pi over 4 here, just like I grabbed the b in this notation. That's why I grabbed pi over 4. So since the b is positive, we're going to shift positive numbers, those on the horizontal axis, shift to the right by pi over 4. All right. So we got a lot of things to think about. Let's break it down. So remember, what was our original period? It was originally 2 pi. But now we're actually shrinking it to 0 to pi. All right, where did it originally start? It originally started at 0. But now we're going to shift it horizontally to the right by pi over 4. That means I'm actually going to start my graph at pi over 4. And I'm just going to put it wherever. I'm going to put it right here. Now, I'm going to start here, and then I'm going to end at, I have to move pi. Now, I actually have to figure this out, so let's calculate it. Pi plus pi over 4 is 5 pi over 4. So this number is going to be 5 pi over 4. Okay, so basically whatever I draw is going to be inside of, and let's shade it maybe as an interval, this little interval. And that has length pi, because if you go backwards, 5 pi over 4 minus pi over 4 is just pi. All right, next step is to cut this up into 4 pieces. Okay, so now this one's a little tricky. We have to do so how do we get that? So this, if this was pi, the halfway mark is just pi over 2. So one way to do it is if we're starting at pi over 4, I'm going to add pi over 2. And now let's just do the algebra. That's going to give us, let's see, times 2 over 2. It's going to give us 3 pi over 4. Okay. So rewind the video if that was a little too quick. But notice I always build everything from pure geometry. So, oh, I don't want to erase that. I want to just add my little tick marks because this gives me my quarter marks, right? I just figured out 3 pi over 4 because that's the halfway point. But then I could cut it up into halves again. Now, we could figure these out. I'm not going to, though. It's actually, let's see, if pi was the original big length, pi over 2 is half, pi over 4. So actually, this is not too bad. This is just 2 pi over 4, 3 pi over, 4 pi over 4, 5 pi over 4. Okay, that's actually nice and neat, nice and clean. Okay, but we got our tick marks. Next, we're going to do vertical stretch by 3. So we're going to go, instead of 1 and minus 1, we're going to go up by 3 and then down by 3 as well. And now we're ready for the 5 points. So what are the 5 points? How do we know which ones to select? So we are doing cosine. So cosines start at the top. So we're going to start at 3 at this point here. Basically at pi over 4, comma 3. Okay, and then we're also going to end up at this at 5 pi over 4 at 3. In the middle, cosine is going to be at its lowest point, so we're going to be at negative 3 in the middle, which is 3 pi over 4. And then those are 3 points of cosine. The last two is where we're going to be at 0. Whew, okay. Now all we have to do is draw our beautiful piece of cosine, which, okay, I didn't do it super beautiful, but let's try again. You can tell, even though I get a lot of practice drawing these, it's still quite the challenge, so probably try to use a pencil for this part. Okay, so there it is. It's stretched by 3. It's compressed and also shifted, so a lot of effects going on. All right. I said I would leave this one for you, but I actually am going to give you one hint before we finish here. The hint is this. The amplitude A is 3 over 4, so we're going to actually compress it vertically. The next thing is, well, look at the sign. Inside of the parentheses, it's not in the correct form. Notice that I have these gray parentheses here. So I basically need to do something where I pull out this 2 from both of these pieces. So let's do it in steps. Let's factor out the 2, and then I'd have parentheses x plus, now instead of 2 pi over 3, we're actually going to have pi over 3. Okay. And then one more thing. Notice I don't have the minus sign. So one more step is we're going to rewrite this one more time. So what that tells us is that the amplitude is 3/4, vertically compressed. Our k is 2. So our period is going to be 2 pi over 2, which is pi. So instead of 2 pi, we've actually compressed our period. And now the last number is the b. And notice I had to pull out an extra minus sign. So the b is actually negative pi over 3. Okay, let's maybe do this in red here. What is that doing? Remember, the b is a horizontal shift. And the reason why we use this extra minus sign is because, okay, I got a negative number here. So we're actually going to shift to the left by pi over 3. So let me just draw the period, and then I'm going to stop and let you come up with the rest of the graph. So remember, originally cosine has period 0 to 2 pi, but that's not our period anymore. Our period is now pi because of the k. So it's 0 to pi. Okay? But we have a horizontal shift by pi over 3 to the left. So basically, one way to do it is just move everything by subtracting pi over 3 from both sides. So we're kind of doing it algebraically. I'm subtracting pi over 3 from 0, and I'm subtracting pi over 3 from pi. So this is going to give me minus pi over 3 on my left endpoint. And now we have to do a little bit of algebra here to write this as 2 pi over 3. So minus pi over 3, 0, pi over 3, 2 pi over 3. So it actually, since I keep using 2's because if you're going to cut things up into 4 pieces, it makes the algebra a little cleaner. So yeah, this is actually going to be our interval now, from minus pi over 3 to 2 pi over 3. And the 4 pieces maybe are a little hard to see, so maybe I'll do them in purple just so that you can see that there really is 4 pieces that we cut this up equally. All right, so I'm going to stop the video here. Thank you so much for paying attention. Thank you so much for taking notes. I look forward to seeing your submissions on Canvas. All right, have a great night. Bye-bye.